Hi, I'm Libby. I'm a software developer and a worker owner at Position Development, and I currently work remotely from Wheeling, West Virginia. Do you have any West Virginians in the audience? No? It was statistically unlikely, so that's cool. And I was a KISS doll, or Kisekae Set System artist from 2001 to 2006. So this here is a preview of a doll that I made when I was in high school, so over 20 years ago. And today I'm going to talk about what the Kisekae Set System is, who created it and why I am trying to revive it, and I'm going to talk about my KISS viewer, Smooch. So what is the Kisekae Set System? It is an open specification for creating digital dress-up dolls. Now, I tend to get one of two responses to that. Either, wow, I love those things. I used to play with those when I was a kid. Awesome. Or I get, why? Why in the world does there need to be a specification for that? What's so complicated about dress-up dolls? Why would anyone make or use this? And the answer to that is in the history of KISS. So KISS was invented in 1991 by a person calling themselves MIO.H on a Japanese bulletin board system. So this was pre-World Wide Web. The internet was really expensive, really slow, but users were trying to create these dress-up doll programs and share them with each other. And while I don't have a lot of information about the motivations behind these creators, it makes sense that if you separate out the program that is used for viewing the dolls and the actual assets for the dolls, you can make the files much smaller and be more efficient, right? So there's a lot of components to KISS, or a few important components. The first is the cell image format. So cells are named after animation cells. And that's because they have a transparent background, just like an animation cell. And they also have index color. And this is a custom image format that was created just for KISS. But you may have heard transparent background, index color, and you might think, well, why not just use GIF? That was invented in 1987, so it was around. So why wouldn't you just use that? Well, I can't really know the motivations, but I do know a couple of advantages that cells have over GIF. And the first is that along with cells, we also have another format, which is the KCF palette format. So a GIF file carries around its own palette. So if you're not familiar with how indexed images work, it's kind of like paint by number. So we have a whole list of all of the pixels in our image, and we can say, okay, this first pixel is pixel number 1, second pixel has color number 2, third pixel has color number 2, and then we look each of those colors up in the palette to figure out how to render it. With a cell, it's the exact same thing. The only difference is that instead of each cell having its own palette, these cells are sharing a palette. And that kind of gives you a little bit more of that file size cost savings, right? You could have your whole wardrobe be coordinated, right? They're sharing colors. You don't have to repeat that information with every single file. The other neat thing about KCF palettes is that it allows for really easy palette swapping, which is an old video game trick where you make something that looks like a new image, but it's just the same image with new colors. And all you have to do for that is change the palette file. You don't have to change any of the cells. So that's a really useful feature of KCF. The third important component of KISS is the configuration file. So we have the images, we have the colors. The configuration file specifies pretty much everything else. So the positions that the clothes are in, what the background color is, and anything else that is important to displaying the doll. And then because KISS dolls had all these files, so we have all these cell files, all the palettes, we have the configuration file, we need to bundle them up somehow. And artists typically used LHA compression back then. That's what was popular in Japan. And you may be familiar with it from because it was really popular with the Amiga computer system. And apparently it's also used a lot with Doom and Quake. And I put this in here before I knew that he was going to be talking. So it's just kind of neat. So 1994, KISS had gotten popular enough that a person called KOS wrote the KISS General Specification, which laid out all the information that was had at the time about how KISS works, what the file format should look like, and all that stuff. And then in 1995 came FKISS, which was the next great leap forward in digital dress-up dolls. So FKISS was invented by an American artist named Dove Sherman and a Japanese artist named Yav. And they added capability for animation, sound, menus, and all sorts of other interactivity. So let's see if I can show you what that looks like. Okay, so who here knows Ranma 1/2? A few of you guys. It's an anime about this boy who gets cursed. And now whenever he gets splashed by cold water, he becomes much more feminine. And then when his feminine body gets hit with hot water, if I can figure out where my mouse is, it is lost. But anyway, he turns back. Oh wait, there it is. So this has like a whole lot of effects. It's got the animation, it's got the interactivity, it's got the sound. So yeah, that's FKISS. That's what they added. There's also FKISS 2, FKISS 3, FKISS 4, 2 different flavors of FKISS 5 that were all added after this. But this was kind of the first edition. So from 1995 to 2005, there was huge growth in KISS. And a lot of that was just like rising tide lifts every boat. Like internet was getting more popular, so stuff on the internet got more popular. And also at the same time, anime was getting more mainstream, and people would like go on to Alta Vista and search Sailor Moon, and they would find these dolls of Sailor Moon and be like, oh, I want to make those. And with that came at least a seeming change in demographics. We don't have any like numbers or anything, but you can kind of look at these dolls from like 1995 and earlier, and they have like kind of a certain theme, which has definitely changed by like 2001. And I would say it's kind of like the fantasy of the hot girl on the motorcycle to a fantasy of owning a ton of clothes that are all really cute. But that's just a generalization. Obviously, there were all types of dolls in both eras. So unfortunately, KISS really started to decline around 2006, 2007, at least in the West, because KISS became a lot harder to make. So that was mostly because new operating systems were coming out, people were upgrading their computers, and suddenly all the tools that all the old tutorials were written for stopped working. This new, or the later audience for KISS was not as technical as the earlier audience. They could not figure out how to make it work largely, or they just didn't want to have to bother because there were all these other alternatives that were coming up that were like ways to play dress up that didn't require you to have this technical knowledge. So we had things like The Sims. You could dress up your little doll, and then you could play in a virtual house with it. We had IMVU, which added social media to your dress-up dolls. And then there were like browser-based dolls where you didn't have to worry about installing something on your school computer. And it was a lot easier to share the dolls with your friends. So because of all these changes, English-speaking kiss making kind of died out by 2010. There are like maybe literally a handful of dolls that came out after that. So if historical reasons explains why KISS was invented and it explains why it died out, it doesn't really explain why we should still care about KISS. If people are still making these digital dress-up dolls with other software, then why try to revive KISS at all? Well, for me, the most obvious reason is nostalgia. This was something that I enjoyed making when I was a teenager, enjoyed playing with. I consider my first publicly shared coding project to be a KISS doll. This is one I made when I was like 16. So that's a big driver for me personally. But another reason is that I think these dolls are important. I think they're like great snapshots of what internet culture was like for this whole time span. And a lot of them have like interesting documentation that are attached to them that explain like the thought processes behind like, why did I choose this subject matter? Why did I choose these clothes? What was it like to make this doll? What is the response I got to my previous dolls? And that is all like really interesting stuff to have, and I want people to have more access to it and be able to see it. Plus, some of these dolls are just, I think, really beautiful. This doll here is one of my favorites, Nigel by Kid and Rick Kramer. Just because like he's a really fun character, and people kind of did that stuff. They would like make up an original character and just give him like ridiculous amounts of clothes. and this character also had like letters from his friends. He had like stuffed doll collection. It was a doll within a doll. I think that's really neat. And KISS had a lot of unique features. So how many of y'all have played with Picrew? Yeah, anybody use Picrew to make their like Twitter icon or whatever? There's like several tools like that are kind of like the most popular present day dress-up dolls, I think. But they really have different strengths and weaknesses compared to KISS. And I don't know of any platform or tool set that has the flexibility that KISS has. So a neat thing about KISS is that I forgot to show this. This is like an example of a very early doll from 1993. So let's see. I can barely read it. Is that Tayatagi?
Yeah, it is.
Okay. So this is a KISS doll, supposedly, that, come on, did that not work? Oh, it opened it up in my other window. Sorry about that. Okay. So this is a Tagi agency. This was an attempt at making Tamagotchi in KISS, which is pretty impressive. So you can like click on one of these eggs, and then you get like a little Tamagotchi character, and then you can like give it a name. So I'm gonna name this one Fran. As far as I know, there's no keyboard input in KISS, so they had to do that. And yeah, so now we've got like a bunch of stats. We can like try to like make this guy happy. Oh, he's sad, oh no. So I can try to make him happy by brushing him. I've got like food that I can feed him, so I can like give him some milk. And some of the Tamagotchis like milk, and some of them hate it and will get mad at you. So like that's really impressive. You could not do that on Picrew, let me tell you that. If you tried to make that in, like, there are some like that are a little bit more like KISS, but even those don't even have capability for animation. So you'd have to like be making it from scratch in some game making platform, like a general purpose one, which which maybe is the right thing to do, but still. So the fourth reason that KISS is cool is that it has an open specification. Your
window is still...
Oh, shoot. Thank you. I should have thought before introducing all this complexity. Has an open specification. So a lot of artists left for things like Sims, which don't have this as far as I know. But KISS makes it, has all the information out there for you to make your own viewers and tools. So for me, the question is not why revive KISS, but why not? It's all there. So, boop, boop, boop. So let's talk about my viewer, which is Smooch. I started this in 2015 when I was at the Recurse Center. What Smooch does is that a user can upload a doll, and then on the back end, we decompress the LHA archive, read the configuration file, convert all of the images to PNGs. Then we serve some JSON representing the configuration file and some HTML to the front end. Then on the front end, we render the doll and enable drag and drop and some special effects. And then the user can play with the doll. So the backend is written in Haskell. Do we have any Haskellers in the audience? One. Okay, cool. Everybody else is going to be totally lost, but it's okay. I'm going to have slides available afterwards, so if you want to examine these in detail, you totally can. It's also the print type is really tiny, so sorry about that. But I'll try to explain everything verbally. So it's written in Haskell. It's using a web framework called FN, which is an awesome web framework. If you are in Haskell, you should try it out. And so we have here a couple routes for uploading our KISS files. So we have route 1 and another route. Both of them do exactly the same thing. They're just two different ways of uploading a doll. When you upload the doll, Smooch first checks to see if the doll's already cached, if somebody else has already uploaded it. And if not, then it starts processing the doll. So Haskell is known for being a functional language, but this app has a lot of imperative code. It's mostly do this, do this, do this, do this. So we copy the file, create the directory, unzip the file, lowercase the files, because I could not figure out how to do case insensitivity at all. But the most interesting part is when you get to create cells in JSON. And that's where we actually start parsing the configuration file and getting all the cells out of it. So for parsing, I'm using a library called Parsec. It's one of the older parsing libraries, and it uses parser combinators, which is just like the phrase sounds like. You're taking smaller parsers that can parse some little bit of information, and then you're combining them into larger parsers that can parse whatever you want. So I made this is a data type that kind of describes every possible thing that somebody could put in a configuration file. It's every bit of data that I might be able to pull out of it. And then we can write a parser that can get all of can read all those lines. And whenever it looks at a line, it's kind of trying each of these parsers in order. So it's going to try to parse it as a cell. And if it can't, then it moves on to the next thing. And that's basically how the whole thing works. So we'll kind of look really quickly at parse cell line in a second, so you can kind of see what that looks like. So parsing something in general is a great opportunity for test-driven development. So this here is a sample configuration that's in my test suite right now that I basically pulled from the spec. I was like, what does the spec say that a configuration file should look like? So I wrote that up, and then I could write tests that said, okay, if I parse this into my Haskell type, what should it look like? And then I could, once I had all that to the spec stuff done, when I actually tried to load real life KISS dolls, every time I ran into a problem, I could write new tests until, you probably can't even read this, but basically it's just adding more and more junk. Like, is there missing data? Are there like weird extra characters? Are people just like tagging ampersands onto the end of random lines that were not in the spec, and yet other players played them, so mine should play them too, I guess. So here's an example of one of the CNF line parsers. So most of the parsers start with looking at the first character in the line. So a helpful thing that they did when coming up with this configuration file is they were like, okay, every line is going to represent something different, and we're going to kind of prefix each line with what the thing is, like a signifier for what you're going to get out of it. So all the cell lines start with this pound symbol, so we know how we're going to parse the rest of it, which is neat. Again, I am going to share the slides, so if you want to look at this in detail, you can check those out later. So once I have a whole list of CNF lines, then I can process those into a type that is a little more structured that I can turn into JSON. So the list of CNF lines, it could have like any sort of random data in it. I don't know if it has everything that I need, and I don't know if it has like maybe multiple, like it could be nothing but 5 copies of the border color, and it would technically be a list of CNF lines. But the CNF KISS data type kind of says, no, you've got to have exactly one description of the border color, you've got to have the window size, you've got to have a list of cells. So yeah, and then we can take whatever value we end up creating of that and use a library called ASON to translate that into JSON. So once we have the configuration file translated into JSON, the next thing that we need is to convert all the cells and palettes into something that we can use on the front end. And I originally thought that this was going to be the very hardest part of this project. But luckily, I was still at Recurse Center when I was working on this, and a person named Mark Dominus was a resident at Recurse at that time, and he volunteered to help me with understanding the spec. So I don't know if you can read it, but the spec was, to me, absolutely indecipherable, because it was just saying stuff like LSB, MSB, had like, it was talking about bytes and bits and stuff that I had no clue about at that time. And he really helped me understand what that stuff meant. So I ended up making a C program that could convert these cells into another format called a portable bitmap. Then we could take the portable bitmap and just use a standard toolset from NetPBM, and then that would translate them into PNGs, and then I could just show those in any browser. So that worked really great. But then a couple years later, a person called Huggable Monad, which is an incredible name, approached me on GitHub and was like, hey, can I translate your cell to PNM program into Haskell so that you don't have to just shell out to this script? And I was like, that would be awesome. And they actually wrote a whole bunch of code to use this library called Juicy Pixels to read the cells in native Haskell. So let's look at how that works. So palette files are actually really, really easy. So palette files are just a list of colors, basically. It's just an array of red, green, and blue colors. So if we can just read, what's the red value, what's the blue, green value, what's the blue value of this color, and then stick it into an array, we're done. Cell files are a little bit more complicated, but not much. So to show you just how simple they are, I've pulled up one of them into a hex editor. So this is actually a cell that is a drawing of Sailor Moon's cat Artemis. And I know, like, if you're looking at it right now, you're like, that doesn't look like anything. But if I can pull this, oops. Also, oh no. we ignored her a little bit too long. Okay, here we go. If we pull this so it's the same size as the actual cell and scroll down, you can actually see the cat kind of in the image, in the bytes. I mean, these are just bytes. So that's exactly how decompressed this image format is. It is not hard to translate. Now I've got to remember to get it. Yeah. Okay. So all we have to do is get the width and height of the cell, and then we just look up each color number until we have, in the corresponding palette, until we have an array of colors. Once we have the width and the height and an array of colors, that's all we need to make a PNG using Juicy Pixels. So that's the back end, or at least all the interesting parts of it. For the JavaScript. So for some reason, in 2015, I was determined to avoid using any libraries. I wanted to learn vanilla JavaScript, and I wanted to keep the project simple. I had this idea that I wanted it to be easy to contribute to. Don't ask me why I used Haskell then, but I thought at least the front end could be easy to contribute to. And I kind of had this idea that using a framework would kind of involve more baggage for potential new contributors. So at first, the JavaScript was just one long static JS file. There was no Webpack, nothing like that. But eventually, finally this year, I converted it to ES6 and started using modules, using Parcel just to make it a little bit easier to develop with, adding some tests with Mocha and Chai. But there's still no libraries. It's still just vanilla JavaScript. So my first try at rendering the doll, I thought I could just take all these PNGs, stick them in image tags, and just spit it out in the browser, and then tell the browser, okay, just position these in the place where the dolls said they should be. And surprisingly, that almost worked. You could look at the page, and it would look just like it looked in a real KISS viewer. The problem was when you actually tried to use the drag and drop, because the browser didn't seem to understand that if there's a transparent area, I expect to be able to kind of click through that transparent area at the thing beneath it. So with this doll, if she's got a long sleeve shirt underneath of the scarf, try to click the long sleeve shirt, and it selects the scarf instead, because that is rendered on top of the other thing. So yeah, you'd have to click way over here to be able to click on the shirt. So the next thing I tried was using Canvas instead, HTML5 Canvas. And at first it was even worse because once you've drawn something on Canvas, it's not they are separate elements that the browser knows about. All it is just one image. So how can our JavaScript know what item of clothing the user is clicking on and what should be dragged around? And the solution ended up being another cool, old school video game trick. And that's a ghost canvas, which is also a really cool name. So you assign a color to each item of clothing, or any item that you want to be clicked on. You draw a second canvas that colors each item with its assigned color, just entirely. Only the transparent parts are not colored. Then when the user clicks, the JavaScript will look up the corresponding pixel in the ghost canvas, and it will see what color that pixel is. So if you click on the dark shirt here, it'll be the color is dark blue. And then we can take that color and look up what item was clicked. And that's how the drag and drop currently works in Smooch. It works amazing. And you can actually, let's see, inspect. I can actually open up, yeah, there's the ghost canvas. And set to display none. And you can see it. So you can go on Smooch and like play around with this and see what it looks like in real life. But that's how it works. So the latest thing that I've added to Smooch is FKISS. This is only FKISS 1, the first version of FKISS. This is event-based scripting. Everything is an event or an action. Actions only happen when they're triggered by events. There are no variables, no conditionals. It is a super simple scripting language. And this here is a blink cycle for a doll. So let me see if I can pull it up. So it's for this doll. So if you watch her face, you'll see her blink in a couple seconds. There she goes. So this code is how she blinks. So basically, when these events go off, all the actions that are inside them happen. So to start out with, we unmap. That means we hide. A cell that is like her eyelids. Then we set a timer for 600 milliseconds, or 6,000 milliseconds. Then we, when that timer goes off, we show the eyelids cell, so it looks like she's closing her eyes. Then we set another timer. When that timer goes off, we hide the eyelids again and set the first timer again. So it's a loop without any actual loops. And the way that this works in Smooch is that on the back end, when we're processing that configuration file, we just have a few more things that we can parse out of that. We have the events, we have the actions, and then we have any arguments that those events or actions can take. And there's really only three. It can be an object number, it can be some text, or it can be just a number. I probably could have gotten more fancy with the types here and said like, well, sometimes those numbers represent milliseconds, and sometimes they represent timer numbers, but I decided not to because I'm lazy. So we start out with some FKISS, and we end up with JSON. Then on the front end, we're going to take that JSON and we're going to turn it into executable JavaScript. And the way that we do that is that we're going to go through each event in the FKISS one by one. And we're going to start out by looking up that event in a sort of map from the event names to some functions that say, here's how we're going to set up the event. And if you want to see all these, you can go, I've got a link for the repo in here. But just trust me, that's what they do. And once we've looked up, like, here's a function that's how to set up the event, then we're going to go through and we're going to set up all the actions that happen during that event. And actions are just functions. So to make an action go off, we just call the function. So we have another map that's from all the action names to what happens when we call that action. So there's a map from unmap to mook unmap, which says, okay, unmap always has an argument of what needs to be unmapped, whether it's a cell or an object number. So we're going to find that object or cell, and then we're going to call unmap on it. A tricky thing about JavaScript is that if you just try to return a method on a function, like as if it's a function, it does not like that. Like that's something that I thought I'd be able to do based on my experience in functional languages. But since I'm doing this weird combination of functional and object-oriented, it's not happy. So what you have to do is you have to call bind on the function that you're returning and tell it what object that you are calling that method on. So that's how the actions work. Then events are just JavaScript custom events. So since we're just using JavaScript events, all we have to do is add an event listener. And then when that event is dispatched, we can have our actions happen. And it works just like anything else in JavaScript. To dispatch the event, we just call this.dispatch event. It's really easy with our custom event, and we give it a name. So that right there is like how begin and initialize work are really straightforward. The one that's tricky ends up being timer, the action that sets a timer. And I originally thought I could just use set timeout and be like, okay, set a timeout for 6,000 milliseconds. The problem is like KISS is like keeping track of the names of these timers, and whenever you make a new one, it's like, or whenever you set a timer, it's like resetting the existing timer with that number. So it got complicated, and it really looks like a mess at this point, and I don't really understand it. But so like timers are definitely the hardest part, but yeah, FKISS works at this point. So at least all the ones that are commonly, all the events and actions that are commonly used in sets. And I guess now it's just FKISS 2, FKISS 3, FKISS 4 that I have to worry about. So let's talk about like where I see KISS going in the future. I would really love it if people started, like more people started making KISS dolls again, and that's why I'm making Smooch. So some things that I've thought about is like, what if we added some support somehow for PNGs? Everybody knows how to make a PNG. Everybody has tools to do it. Nobody has tools to make cells. And artists just expect artists don't really know how to work with index color. So that would add a lot of convenience. So that's something I've been thinking about. The other thing is like, how can we encourage people to make tools and to make their tools like open source so that everybody can work together to maintain them and improve them? So I'm really trying to like, there's like maybe 10 of us who are making KISS right now. We've got like a little Discord server. Let me know if you want on the Discord server. And I've been trying to like kind of help people understand like, yes, you can learn how to code. Please learn how to code so we can all work on these tools together. Also, I would love it if Smooch could have more contributors. So if Smooch sounds fun and interesting to you, I would love to have you on the project. Please talk with me after the talk. So that's all I've got. Thanks so much for coming to my talk. You can find me at libbyhoracek.com. You can find my workplace at positiondev.com. Smooch is at smoochdolls.com for now, at least. I really haven't productionized it, so who knows when it's going to crash. Check it out while you still can. And then I have the GitHub for Smooch, so you should definitely check out the Smooch GitHub. And there's the slides right there. Big thanks to Clockwork Prince, who is a person from that aforementioned KISS doll Discord, who has helped me so much with learning about KISS's history, and William Miles, who made the KISS viewer that I was showing Tagi agency on. That's like the only one that's usable on Mac, so I'm greatly indebted to William Miles for keeping that going. So yeah, thanks.